Welcome to today's lecture. Because of the seminar at the department today, I may not be able to be physically present in today's lecture. So we go online. Going by our course, the course contents, I guess the next topic in line is micronutrients. So we are going to look at the micronutrients. Micronutrients, even as the name implies, are nutrients that are required in smaller amounts for proper functioning of the body. Even though in smaller amounts, they are highly needed by the body to function optimally. They include the vitamins and minerals. You all are familiar with these words. So you will now have a deeper understanding of these nutrients, which you already know as we progress in the course. It is expected that you should be able to explain the classifications, chemistry, functions, metabolism, food sources, daily requirements, toxicity and deficiency disorders of vitamins and minerals by the time we are done with these discussions. But for this particular course, we are taking vitamins. What are vitamins? They are organic compounds required in minute amounts for normal growth, maintenance, reproduction, and general well-being. Remember, protein, carbohydrates, lipids, which are the macronutrients, are also organic compounds. So let's look at the characteristics of vitamins. What makes it distinct from these other organic compounds? They do not enter the tissue structures, unlike the protein. They do not undergo degradation to provide energy. Rather, they play important role as coenzymes. In other words, they work with the enzymes in the proper metabolism, activating the chemical reactions that promotes proper metabolism of the macronutrients. They are mostly provided in the diet, meaning that just a few of them are synthesized in the body. It has to come from diet. Classifications of vitamins. Vitamins are broadly classified into water-soluble vitamins and fat-soluble vitamins. Again, we will commence with the fat-soluble vitamins. By the right side of this slide, you will see the classification of fat-soluble vitamins. You have the vitamin A, vitamin D, vitamin E, and vitamin K. We take them one at a time. The vitamin A. Among the four fat-soluble vitamins, vitamin A is of public health importance in Nigeria. Vitamin A occurs in two forms. You have the animal form and the precursor of provitamin A form. The animal form is the form at which the body utilizes vitamin A, and they are called the retinols. There are three forms. That is, number one there, these are the chemical structures. They are the alcohol, the retinol, The second one there is the aldehyde. You can see it's having the same structure with carbohydrate. Then the third one is the retonic acid. They are of the animal origin. That's the form at which the body utilizes vitamin A. The provitamin A are derivatives of certain carotenoids as listed there, here in the slide, on the slide. The most common is the beta carotene. They are derivatives. Basically, I say that they come from, they are more of plant origin, meaning that they they need to be converted to the animal form before the body can utilize it. That's why they are referred as provitamin or precursor, meaning that conversion, when they are converted, they can be converted to vitamin A for body to utilize to still serve the sun purpose. So let's look at the food sources of vitamin A. Like I earlier said, the animal sources, we have the liver, oil, butter, milk, cheese, egg yolk, and so on. The plant source, any orange colored, yellow colored, or red colored plants is expected or is linked to having a beta carotene content. So like you have tomatoes, we have the carrots, we have the yellow green vegetables, we have the spinach, mangoes, papaya, yellow corn, sweet potato, orange flesh sweet potato. There are so many of them, 1001. There are also local fruits within our different vicinities that have these colors. It's an indication that they may have a trace of beta carotene in them, which is a precursor of vitamin A. Then the daily requirements. Adults require about 9,000 to 1,500 microgram of retinol. That is the animal form of vitamin A. Those that are coming from the animal source, as listed in the sources there. Then 1,800 to 300 microgram coming from the precursor. That's the carotenoid form. Children require higher amounts of vitamin A, though not specified yet. The metabolism, that's it, just like we discussed in the macronutrients, the absorption and the utilization of vitamin A. Vitamin A and its carotene precursors are absorbed in the small intestine. Again, carotenes are converted to retinol in the liver cells. That's the vitamin A form, like I said earlier. And it's the liver cells that primarily perform this function. And about 95% of the retinol are stored in the liver as retinol palmitates. The liver again stores retinol. Retinol transported in the blood are bound to retinal binding property. When I made that statement that the liver again stores retinol, remember in the macronutrient metabolism, liver converts excess glucose to glycogen and store excess glucose and glycogen in the process of glycogenesis, and reconvert the glycogen back to glucose in the process of glycogenolysis. That's the function of the liver. Here in the vitamins, that's the micronutrients, you can also see the liver playing that function again in the storage of vitamin A and possibly other micronutrients. Then the normal blood level of vitamin A is 18 to 60 microgram per deciliter of blood. Functions of vitamin A: it promotes vision, promotes reproduction, and it helps improve the structure of the skin and mucous membrane. Also help in the formation of bone and teeth. Growth, also promotes growth. And importantly, they act as antioxidant, the beta carotene. Antioxidants, we know, helps in preventing the oxidation of free radicals that causes disease in the body. So these are the functions of vitamin A when you are maintaining a normal balance or requirement of this nutrient. There are deficiency disorder that goes with vitamin A. That is when an individual is not meeting with the nutrient requirements. Remember I said earlier I've given the range between 9,000 to 1,500 for adult requirements, meaning that from diets on a daily basis you should be meeting with such a requirement. So deficient when it is not up to, you are not meeting with that range, person is possibly or likely to suffer from night blindness, not able to see at night. We all know about that, linked to vitamin A. Low sperm development, keratomalacia, that's a serious deficiency disorder that affects the cornea. In dry, scaly, and rough skin. So for those of you that wants to have shiny and fine looking skin, you have to improve your vitamin A intake and ensure that you meet the requirements on daily basis. So you ask yourself, how much do I take this vitamin A rich foods? The plant and the animal source. A question for you to answer. Toxicity, that is taking vitamin A in excess. The diseases or disorder that comes with that is alteration of the skin and the mucous membrane development, hepatic dysfunction, that is has to do with the liver, headache, drowsiness, the peeling of the skin, especially around the mouth. This toxicity or these symptoms may be rare for us here, this part of the country, because it seems that a lot of people do not even meet with the requirements. That's why I said earlier that is of public health importance, because government try to see what they can do to boost vitamin A requirements. You see, even during postnatal, at the infant stage, children are being given a vitamin A supplement to help to boost the intake. But it does not mean that you should maybe go for supplement, because abuse of drug supplements of any type, vitamins, can also result to that excess intake, and these symptoms may manifest. So to avoid toxicity in vitamin A intake, avoid supplements. Try to obtain this nutrient from diet. Let's look at the vitamin D. Vitamin D is another example of a fat-soluble vitamin. Vitamin D is synthesized, the inactive vitamin D that is found in human is known as 7-dehydrocholesterol. Even as from the name, it's synthesized from the cholesterol in the liver and now transported to the skin for activation. And we commonly know that vitamin D is gotten from early morning sunshine. Is that inactive form that is activated by that ultraviolet sunlight. That is, we call it early morning sunlight. It helps to activate the inactive form of vitamin D on the skin. Then ergosterol is a provitamin, that is a precursor of vitamin, also known as vitamin D, that is found in plants. It is not a nutrition importance anyway. So the active form of vitamin D is known as calcitriol. The active form of vitamin D is known as calcitriol. So the vitamin inactive form is converted or is activated to vitamin D, which is the calcitriol, on the skin and this process is accomplished by the ultraviolet light. Then absorption, again, vitamin D is absorbed in the upper and the middle part of the small intestine with the help of the bile salts. Upper side, that's the duodenum and the jejunum. Absorbed vitamin D is transported to the blood by the chylomicrons droplets in combination with the serum globulin. So you can see again that vitamin D absorption is with the fats, dietary fats, and is also stored with body fats. It has to do, just like the name is, fat soluble vitamins, and you can see so far that even their sources also from fatty food. Dietary sources again: fish oil, egg yolk, margarine, butter, cheese. And I know quite a number of you may not have known that maybe vitamin D is found in food, because we commonly believe that vitamin D is obtained from early morning sunshine. You can now know that what the sun does is to activate the D3 inactive form of vitamin D that is synthesized in the liver, or by the liver in the body. Daily requirement of vitamin D3. Adults need about 2.5 microgram. Higher amount of 5.5 microgram is required in pregnancy, lactating, including infants and growing children. The functions of vitamin D: it plays a role in regulating the intestinal absorption of calcium and phosphates. Yes, it plays important role in that aspect, and also in the mineralization of bone, because vitamin D, we all know, is linked to bone formation and mineralization. Then deficiency disorder, that is when one is not meeting with the required daily intake. It can lead to rickets in growing children and osteomalacia in adults. These disorders are related to poor formation of bone. Then toxicity again: excess intake of vitamin D will result to anorexia. That's an eating disorder that is characterized by extreme dieting. Thirst, that's frequent feeling thirsty. Constipation in some individuals, and excessive urination. Remember, all these symptoms, they are the general symptom, but it affects individual differently, maybe depending on the body physiology. But these are the general symptoms. And again, toxicity in vitamin D can also be facilitated by intake of supplements also. So in other words, ensure you eat that food sources of taking enough food sources of dietary vitamin D, so that you can get it from diet rather than taking or abusing supplements. I use the word abuse because I know most of you that take supplements don't do it without the recommendation of a physician. They buy it over the counter or from people that are selling it, that are not even physicians. That is not a good practice for your health. The vitamin E, another name for it is tocopherols. We call them tocopherols, and you'll be hearing that. Tocopherols again are of 4 types as listed on the slide here. But the most common, or the active form of vitamin E, is the alpha tocopherol. Free tocopherols are readily absorbed in small intestine with the help of bile salts. Again, the bile. And we know bile is linked, when we discussed the macronutrient fat, that was when we were mentioning bile, how the liver synthesizes bile, and how bile helps in the breakdown proper metabolism of fat. So you can as well see in these fat soluble vitamins, bile all again is helping in the absorption and of these important vitamins in the body. Then absorption of vitamin E is transported to the liver, where it gets incorporated into lipoproteins. Lipoproteins are also a body fat that helps in transporting cholesterol to all parts of the blood. We know that. Then they are later carried by blood to muscle tissues and to the adipose tissues for storage. In other words, tocopherols are stored in the adipose tissues and the muscle tissues in the body. Dietary sources of vitamin E: cotton seed oil, corn oil, sunflower oil, wheat germ oil, margarine, peanuts, soybean, and cabbage. You can see that majority of them are of plant source. Vitamin E, the healthy ones, are gotten from the plant oil and source. Functions of vitamin E: as antioxidant. It has antioxidant property. That's the major function of vitamin E. It also helps in the reproduction, because reproduction, sorry for that mix-up, that impaired spermatogenesis is in rat. That is the deficiency, should be a deficiency disorder. So it's just that it helps in reproduction, meaning that it helps in the sperm development. Deficiency will now result in what I have in the bracket. I'm sorry about that. The daily requirements: children require 14.9 to 22.6 milligram per day, while adults require a higher dose here, 29.8 to 37.3 milligrams per day. Normal blood level is between 1.1 to 1.2 milligram per deciliter. Then deficiency disorder, that is when you are not meeting with the requirement of vitamin E, to result to muscle weakness and loss of muscle mass, as well as destruction of the red blood cell, or hemolytic, we call it hemolytic anemia. The last but not the least, vitamin K. Again, there are three forms of vitamin K, which includes vitamin K1, K2, and K3. But the two naturally occurring forms of vitamin K are the K1 and K2. K3 is synthesized. Then metabolism: vitamin K is absorbed in the small intestine in the presence of a bile salt. Functions: blood, it helps in blood, promotes blood coagulation, and also acts as calcium binding protein. It helps in transportation of calcium in the body. Dietary sources: you have plant sources. That's vitamin K1 is present in green leafy vegetables such as alfalfa, spinach, cauliflower, cabbage, soybean, tomatoes, and I think we are in these are most of our locally or traditional vegetables, the leafy green vegetables. Then animal source, basically the intestinal bacteria synthesize this vitamin K. So I guess that's why I'm classifying as the animal source, because it's synthesized in the body by intestinal bacteria and other bacteria. Deficiency disorder is very rare, maybe because it's contained in most of our local or traditional vegetables, and again possibly because the intestinal bacteria is synthesizing them, and maybe that's why they are found in feces, but they are not excreted in urine, but they can be found in feces. So this all about the fat soluble vitamins. You can as well read from other sources and come up with your questions in the next class. I have to be physically present by the next class so that we can discuss the water soluble vitamins. But before then, I would like you to the general lesson to learn from these fat soluble vitamins, that you can see that one, they are absorbed in the small intestine, again just like the macronutrients. But importantly, they are stored, they are absorbed with fat, dietary fats, and they are stored in those that are stored in the body, they are stored with body fats. They also help in growth. And again, when you look at the food sources, it's almost from the fat, how do I put it? Fatty food. Fatty food. That of the plant sources are majorly fatty food. So that justifies the name fat soluble, meaning that they can only be soluble or absorbed with fats, unlike the water soluble counterpart, which we will know or get to know about in the next lecture. Bye bye. See you in the next class. Thank you for listening.